All right, hello everyone, and thank you for joining us for the 7th ASCLD FRC Lightning Talk episode. I'm Ed Cisco, and I'll be your moderator today. Today's session focuses on cognitive bias in forensic science. The Lightning Talk series was developed to provide a platform for brief presentations that allow for the community to share opinions, spark ideas and collaborations, highlight recent research, and convey information. The format of the session will feature 3 speakers, each with 7 minutes and no more than 3 technical slides. Following the presentations, I'll have a brief question and answer session. If you have a question during any of the talks, please use the chat feature to submit your question. Today's presentations will be recorded and be made available for those who are unable to attend. However, the question and answer session will not be recorded. Also, please make sure your microphones are muted. Today's episode will feature Bethany Growns, a postdoctoral research scholar at the University of Exeter, as well as Hilary Hamnett, a lecturer at the University of Lincoln, and Jeff Kukucka, associate professor at Towson University. With that, I'll turn it over to Bethany, who will be speaking about cognitive reflexes in forensic science.
So thanks for inviting me to be here today. My name is Dr. Bethany Growns, and I'm a cognitive psychologist from the University of Exeter. And introduction, I'll be talking about cognitive reflexes in forensic science. So research has been growing over the last couple of decades, scrutinizing what's known as cognitive bias in forensic science. And this research has shown that forensic scientists sometimes make decisions that are influenced by irrelevant information, something that can lead to errors and even wrongful convictions. So I need to take control. However, there's a huge disconnect between what cognitive science means and what the law means by bias. When the legal system talks about bias, what they're referring to is deliberate, intentional, and unobjective partisanship. This basically means that when an expert witness is biased, their judgment has been unduly influenced by the party who hired them or the outcome of potential litigation. When the law talks about bias, they're referring to a professional failure of a testifying expert in not following their duty to the court by remaining impartial. And this is seen in legal systems across the world. In the US, expert evidence needs to be fair, objective, and non-partisan. In the UK, the criminal procedure rules require expert evidence to be objective and unbiased. Even in Australia, the Uniform Civil Procedure rules require that experts assist the court impartially. However, when cognitive scientists talk about cognitive bias, what they're referring to is mental shortcuts that we've developed over tens of thousands of years to help us process the extraordinary amount of sensory information that we receive from our environment. In a way, these biases or shortcuts are better thought of as cognitive reflexes, which, similar to other reflexes we have, like knee-jerk reactions, are largely unintentional, unavoidable, and unconscious. Broadly, when we talk about bias, we mean the way that humans tend to draw on irrelevant information around them to help them make decisions. For example, one of the earliest examples of this is when a bunch of psychologists asked 2 groups of people to estimate the number of African countries in the United Nations. Before they asked for their estimates, they randomly showed one group a roulette wheel that had landed on a high number and another group the same wheel that had landed on a low number. Despite the roulette wheel being completely irrelevant to the number of countries in the UN, people that saw the high roulette number were anchored to it and gave higher estimates of the number of African countries than those that saw the low roulette number. Similarly, court judges will award higher damage amounts in hypothetical injury cases when prosecutors seek high compensation than judges not given a monetary value to anchor to. So in this study, judges who received an anchor in this hypothetical case awarded an average of over $1.2 million, while those not given any anchor only elected to award an average of $800,000. So this is just one cognitive reflex out of many known as the anchoring effect. And similar things probably happen in forensic science. For example, you could imagine that a fingerprint examiner could be anchored by a decision made by another examiner in an A/B comparison if they were told what the other examiner's decision was. In forensic science, research has shown that forensic scientists can be just as unintentionally and unavoidably impacted by irrelevant information when they make decisions as any other human decision maker. No one can avoid these cognitive reflexes simply by trying to or trying to be objective. Our brains just don't work like that. However, these cognitive reflexes are not the same as bias in the legal system, the intentional and deliberate partisanship that the legal system refers to as bias. When we talk about bias, when cognitive scientists talk about bias, we're talking about a cognitive reflex that happens unintentionally. It's not a personal, professional failure to remain objective. It's an inescapable part of how all of our cognitive systems were built. So going forward, it's important that we reframe how we talk about bias in forensic science so that we can make sure that both the cognitive and the forensic scientists are on the same page in trying to fix these issues that cognitive reflexes can cause. They can be a problem when they lead examiners to unintentionally making incorrect decisions. And there are ways to fix these problems. For example, if a fingerprint examiner could be anchored by another examiner's decision, you can simply withhold that information from them until they've made a decision. I believe one of my co-workers will be speaking a bit more about that later as well. But we have to come together to help solve these issues. Forensic scientists know how to apply scientific techniques and methods to crime scenes and evidence, just as cognitive scientists and psychologists know how to apply scientific techniques and methods to studying the human brain and behavior. But we need to understand how the human decision-making aspect of forensic science works before we can develop and implement empirically validated and tested ways of reducing cognitive biases. But to do that, we need to start speaking the same language to make sure we're on the same page. Cognitive reflexes are not the same as legal bias, but we do need to understand more about them and more what causes them. Design systems and workflows to reduce them, to reduce errors, and to reduce the impact of human subjectivity in decision making. Ultimately, if cognitive science and forensic science can come together and start speaking the same language about these psychological processes, we can work together to make forensic science more bulletproof. Thank you.
Okay, thank you, Bethany. Next up, we have Hilary. Sorry, I didn't realize you're at the end of your slides. Next up, we have Hilary, who will be talking about cognitive bias in forensic toxicology.
Hi, so my name is Hilary Hamnett. My background is as a forensic toxicologist, and as you can see from the slides, I'm now at the University of Lincoln, and I want to talk about how cognitive bias affects my field in particular. So what does a forensic toxicologist do? So if you're not familiar with what we do, we're trying to answer this question. So have alcohol, drugs or poisons played a role in a death or a crime? And the kind of crimes that we deal with can be really simple cases, so things like drink driving or drug driving, through to more complex things like drug-facilitated sexual assault. The kind of deaths that we get involved with tend to be things like sudden death, so deaths referred to the coroner or the medical examiner, but also we can get involved in things like homicide, so where people are stabbed or shot, for example. Now, we rely very heavily on analytical chemistry. So it's basically our job to take some samples, test them, decide whether there's actually something present, and then try and explain what that means to the customer. And so we will use techniques, things like gas chromatography, liquid chromatography, mass spectrometry. And because of that, there's been a view in the field, and I would include myself in this until more recently, that our field must be objective, right? Because machines are making decisions, so how can those decisions be biased? And because of that, we've kind of been a bit slow off the mark to try and address this within the field. And I did some work with a cognitive psychologist called Rachel Jack at the University of Glasgow. And together we looked at what was going on in the field, and we found that actually there's still a lot of subjective things happening within forensic toxicology. So a lot of subjective comparisons, decision making and interpretation, and I'll talk about those in a minute. So we found there are 3 key points in a tox case where bias can become an issue. So the first thing is, how do we decide what tests to do? So the first thing that will happen to a tox case, it comes into the lab, a toxicologist or a trainee will look at the case, they'll look at the circumstances, and then we'll decide which drug tests to do. So although there are some really good techniques out there that can do, 100+ drugs, there isn't like a single catch-all test that will test for every single drug. So there's always going to be some kind of element of picking and choosing at this point. And the more picking and choosing there is, the more scope there is for bias. And I did a survey a few years ago, I'll talk about this at the end, of international toxicologists, and I said to them, how do you make decisions about what tests to do? And a lot of people described to me what I would call a rule of thumb. So they said, okay, if someone's under 50, we do this. If they're under 16, we do that. If they're over 80, we do that. And not a lot of this stuff was particularly scientific. So a lot of it was basically based on assumptions that people were making about what drugs people use at different age groups, and also on, and this is the really important part, on the previous experience of the toxicologist. So the toxicologist said, well, I've seen this before in the past, so I'm going to test for this in the future. Now, the second point in the case is when someone comes to say whether or not a drug is actually present, so the identification part of the case. And in this situation, it would be an analyst or a technician, and they would be doing a really simple comparison between 2 images. So they would get a mass spectrum or a chromatogram, and they would have to say, is the chromatogram from the sample, is it a good match for the drug standard? And that, I mean, I'm oversimplifying it a little bit, but that's basically what they're doing, is they're looking at 2 pictures and saying, how similar are they? And that can really be affected by contextual bias. So if, as in a lot of cases, it's a simple decision, that's great. If it's not a simple decision because the sample's really dirty, or there's not very much of the drug present in the case, which can be a real issue in post-mortem tox work, the more we know about the case, the more that decision can be affected. So if we have what might technically be termed an iffy match, and you know that the person in the case took the drug or they were prescribed the drug, you can subconsciously upgrade that iffy match to a definite positive. And the opposite is also true. So if you look at the drug and you think, actually, this doesn't seem to fit within the case, I'm going to downgrade that subconsciously to a negative. So you can have exactly the same scientific data and it's interpreted in 2 different ways because of what the analyst knows about the context of the case. And then the final part is this interpretation of drug results. So tox is a little bit different to other fields. So we do need to know something about the case to do our interpretation well. And that's because there are things like drug tolerance. So if you have someone who takes a drug like an opioid every day, chronically for years, they will develop tolerance to that drug. And the same dose to them might just be a normal dose or a therapeutic dose. It could be fatal in someone who's never used that drug before, so someone who's a naive user. So we do need to know something about the case. But the problem comes when we don't make it clear to the person who reads the report that we have used the context. So we often present our data as purely scientific decisions when actually the context has been involved. And then the other problem that can come in interpretation is confirmation bias. So we will often be told at the start of the case that the police have a theory about what happened. We think this happened. Or if it's a sudden death, the family might have a view about what happened. And we can really easily end up with tunnel vision and just think about that theory that we've been told and not think about the fact that there can be other perfectly reasonable explanations for the same set of results. So I'll just finish off by talking about a couple of papers in this area that I published. So the first one is the survey of toxicologists that I mentioned. This was with Rachel from Glasgow. So it was a big conference in Brisbane in 2016. And if you look at the paper, it was published in Science and Justice in 2019. You can see the kind of information that toxicologists get, and also the really huge variation in how much different people get in different parts of the world. And then the second one was with Itiel Draw at UCL, and we did an experiment where we had quite a big group of participants. We gave all the participants the same scientific data, but we gave half of them potentially biasing information. And I mean, things about the case circumstances, the ethnicity, the gender, the age of the people. And we gave the other half no information. And you can see in the paper how that information affected the decisions that they made. And that paper's open access, so it's free for anybody to see. So thank you very much.
Thank you, Hilary. Finally, we have Jeff, who will be talking about understanding and avoiding cognitive contamination.
Me? Okay, should be able to hear me now. Excellent.
Yep.
I'm Dr. Jeff Kukucka from Towson University, and I'm here to talk about understanding and avoiding what I call cognitive contamination in forensic decision making. As Dr. Growns nicely explained, bias has a bad rap. I am a psychologist who studies bias, and I hate the word bias because people interpret it as a moral failure or a competency failure, but it's none of those things. It's just a byproduct of how our brain works, as she nicely explained, and we can't control it any more than we can control other reflexes like blinking or sneezing. There are various sources of bias that have been identified in the research literature. At the bottom here, you'll see citations to a few papers that describe these sources of bias in more detail, but it's really levels 2 through 5 of this sort of taxonomy of bias that have received the most amount of research attention. So I want to give you a quick overview of these 4 potential sources of bias. The first, at level 2, called reference materials, is primarily an issue for the pattern comparison, pattern matching disciplines of forensic science. This refers to the fact that when people are comparing 2 stimuli against each other, it's actually better to analyze each stimulus on its own before jumping right into the comparison. The research would suggest that if you jump right into the comparison, you're likely to experience a sort of tunnel vision where you're inclined to either look for similarities or look for differences, disproportionately so. Whereas if you analyze each sample separately before making that comparison, that tendency decreases, and you actually elicit more information from the samples, whereas otherwise you might overlook information that you would otherwise deem important or diagnostic. The third level of this taxonomy, contextual information, is the one that's received by far the largest amount of research attention. This refers to situations where an analyst's knowledge of any sort of task irrelevant information, not unlike what Dr. Hamnett was just describing, can sway the results of a subjective opinion or subjective analysis. To give one example of this among many, we recently conducted an experiment in which we gave identical medical information to professionals, and we wanted to see how irrelevant contextual information impacted their decisions about manner of death. So what we gave them was a case file that described the injuries to a child who had since deceased, and we manipulated 2 details between those 2 different versions of the case file. Some of the professionals were told that the child was Black and was brought to the hospital by the mother's boyfriend. Others were told that the child was white and was brought to the hospital by the mother's mother, so the maternal grandmother. Despite the fact that the nature of the injuries and all of the medical information was exactly the same, those 2 irrelevant pieces of information influenced their manner of death opinions. So in the one condition where the child was Black, they were more likely to believe that the death was a homicide, whereas in the condition where the child with the same injuries was white, they were more likely to judge it as an accident. So I think the point made by Dr. Hamnett can't be overstated, which is that what the crux of bias is that 2 people can look at the same scientific data and come away with different interpretations as a function of their mindset. And of course, by definition, at least one of those interpretations has to be incorrect. At the 4th level of the taxonomy, we have the influence of base rates. So this is where an examiner's prior experience can influence their judgment. If you get accustomed to seeing something over and over and over again, you become more inclined to see that thing in the future. In other words, when something different comes up, it becomes harder to detect it. And we've seen this not only in forensic judgments, but also in TSA agents screening for weapons at airports. We've seen this in medical doctors screening x-rays and professionals screening for fake IDs, for example. This is also a pretty pervasive phenomenon. Lastly, we have organizational factors, namely stress and allegiance. I'm sure I don't have to tell the folks in this room that being a forensic examiner and working in a crime lab can be a very stressful and demanding job. And it probably comes as no surprise that psychologists know that stress affects our brain and affects our decision making. So it's important that laboratories implement measures to make sure that they're protecting their employees' well-being, which will also serve to maximize their performance. In terms of allegiance, there can also be unconscious biases associated with working for one side of the adversarial system. That's actually been demonstrated with psychologists as well. When psychologists are asked to perform evaluations, they tend to use these measures that are supposedly objective, but they produce outcomes that are more favorable to whichever side they have been hired by. So again, all of these things are unconscious, but fortunately there are things that we can do to mitigate the effects of these biases. In 2015, the U.S. Department of Justice, specifically the National Commission on Forensic Science, released a report on the impact of task-irrelevant information in forensic analyses. And what that report said, among other things, is that forensic science service providers should only rely on task-irrelevant information when performing analyses, and laboratories should take steps to avoid exposing its analysts to any information that is task-irrelevant and therefore might be potentially biasing. Unfortunately, however, it looks like at least some laboratories are still lagging behind in that respect. This graph here shows the results of an analysis of evidence submission forms from a few hundred crime laboratories. I think there were specifically fingerprint laboratories across the United States, showing that examiners are routinely exposed to potentially biasing irrelevant information that is not necessary to perform the essential function of their job, but could essentially could lead them to an incorrect conclusion by creating bias. A few years ago, we also wanted to get a better sense of how exactly examiners themselves understand the issue of bias. So we surveyed several hundred examiners from all around the globe, and we asked them, among other things, do you believe that cognitive bias is a problem in forensic science in general, in your specific discipline, and in your own personal work? And we saw an interesting pattern here. The good news from our perspective is that a majority, 71% of examiners, felt that cognitive bias was a cause for concern in the forensic sciences in general and that it should be addressed. However, when we asked that same question about one's own discipline, that number decreased to 52%. And when we asked that same question about one's own personal work, that number decreased to 26%. So this is not uncommon in psychology. There's a phenomenon called the bias blind spot. It is easier for us, myself included, to detect biases in other people than it is for us to detect those same biases in ourselves, because we all want to see ourselves as unbiased. So what we have here is a lot of people who are motivated to fix the problem, but everyone sees it as a problem for others, but not themselves. We also wanted to get a sense of what do examiners themselves see as a good way to address the problem of bias in forensic laboratories. So we asked them, do you think that examiners should be shielded from task-irrelevant information? And about half, 49%, said yes. Or if you're a pessimist, 51% said either no or I'm not sure. And we know that that is one of the more, if not the most effective way to prevent biases from operating. Instead, a majority, 71%, felt that they could avoid bias by simply setting aside one's expectations. And unfortunately, that's not how it works, right? Because bias is so deeply ingrained in our brains, it's not something that we're even consciously aware of. It's not something that we can flick on and off like a light switch. No amount of willpower will overcome bias on its own. So what can we do to prevent this problem? For the past few years, I've been serving on the OSAC for Forensic Science, the Human Factors Task Group, which I'm guessing most, if not all of you, are familiar with. And what I'm about to show you are the most common issues that are discussed in those subcommittees. First, the use of blind proficiency testing to get a sense of the accuracy of individual examiners, labs, etc. There's a big push being made for this, and the fact that it's blind is obviously important because we want the testing conditions to be as realistic as possible. It is becoming more common for laboratories to incorporate proficiency testing into examiners' casework, but unfortunately, in many of those cases, the difficulty of proficiency tests doesn't really mimic the difficulty of actual casework. So that's another big hurdle that needs to be overcome. Secondly, limiting exposure to potentially biasing information. There is a really nice paper by the late Brian Found in which he discusses how his handwriting laboratory actually met to review the content of their evidence submission form and remove any information from it that was unnecessary and potentially biasing. More and more laboratories are doing that to make sure that fact finders can have as much confidence as possible in the independence and objectivity of their judgments. Blind verification. So anytime an examiner makes a judgment, having that judgment verified not only by a second examiner, but by a second examiner who's unaware of the first examiner's opinion, so that their judgment is also independent. And finally, communication issues. This is a hot topic right now at the OSAC. When analysts are communicating their opinions to others who are not experts, police, judges, juries, and so on, it's important that they communicate those opinions in a way that those other parties are going to understand. Not overstating their conclusions, being transparent about what information they relied on in arriving at those conclusions. In essence, we want to make sure that those non-experts are not giving either too much or too little weight to the conclusions that are reached in your laboratories. That's obviously a lot easier said than done, but this is another area where there's a potential, potentially very fruitful collaborations between psychologists and forensic scientists in terms of actually collecting data on the most faithful way to report one's conclusions. Thanks for your time. That's all I have, and I welcome your questions.